Hi, and welcome to this Vertex Normal editing tutorial in Modo. So I will talk about this over here I've made, and I will introduce into different topics like taking care of the shading in Modo and take a look at the controls you have on the materials. Looking also at the basics of the Vertex Normal editing and giving some tricks and useful tips on the mechanical parts that you can make for this kind of shapes. As you can see, there is a good amount of highlight on the cutting edges, and it brings a lot of details to it, even if that's running in a low polygon count, right? And that's not driven by any trim sheets or decals or normal map baking over it. It's just driven by the bevel over here. So let's take a look at the different sections. We will talk about the different way of shading in Modo. And for that, I will start with the first one, the most obvious one, is the shading set by the material. So here I have this mesh that have no maps, that just the UVs and the weight maps. And this object have actually just the base material, so no material sets. And if you take a look at the basic and standard default settings, you have here in the surface normal the smoothing value and the smoothing angle. And by default, it's set to this weight by polygon area and increased by smoothing angle, squeezed by hard edges this way. So actually we have 40 degrees, right? So if I higher this value to about 90, for instance, we still have this value between those two faces. So it means that there's no smoothing in between. But as long as I go to 91, then everything looks smooth, right? So here we are defining the way the cut and the hard edges are set by the material itself. So I will go back here, and here we have the material set for this object. I will show a second object that is the hard edge workflow. So this one have this material, and this material is set actually to 179. It didn't make sense to go any further at an higher value. So let's pretend that everything is smooth with this. And from that, you can still have some control over the shading with some overriding data. And the overriding data is the hard edge data. So over here, I have nothing set in the maps, in the other maps. And I will go to the games tools over here and click on pop-up Vertex tools. So the menu is named Vertex Normal Tools because you can use some of those into the Vertex Normal Tools, but actually this is just about hard edge workflow, okay? So just to make sense, if you select all the edges or just select nothing and press harden, then we have an hard edge map that is created over here. It's kind of a selection set. So you can basically get the selection of those hard edges that define that there is a break between two faces. Okay, so it kind of override the material data. So as long as you create some hard edge, you create and define your own settings. So here, for instance, I soften the data between this face and this face, so it creates some smooth graduation between those two faces, right? And it's overriding the data and the way the shading is done into the material itself. So this is one way to control the shading. And the third one is with the Vertex Normal Map. So over here, I have the same material as right before with this value, okay? And we have the material set to the same value over here, with weight by polygon area, crease by smoothing angle, and crease by hard edge. But then we will set, for instance, everything, all the edges. I will select them all. With this, I will set them to be hardened. Okay, so it creates the hard edge map. But now, as long as I go to the vertex map menu and click on set vertex normal, I will apply the smoothing angle by 100%, and now it's setting the vertex normal from this value. So as you can see, everything is smooth now. If I delete this and go back to the settings and set the vertex normal using the smoothing angle, and it will so read to the hard edge and use those hard edge to guide the vertex normal data. So if I go to the view and show the vertex normal over here and press the K button, the K key, I can change the size of it, okay, just right here, just to make them more visible. And as you can see, at every point we have 3 different data that is created. So it means that when you are exporting this to a game engine, Unity or Unreal, you will get those data preserved. And so it means that for every vertex, it's kind of a splitted object with this face unique, this face unique, this face unique, okay? So actually, we have this set vertex normal data over here. So even if I select this edge and click on soften, it didn't soften it anymore, right? Because the vertex normal map is overriding the hard edge, and the hard edge is overriding the material. So to sum up this and make this differently, I have to set the vertex normal by myself. Okay, so for instance, if I select those faces and then go to the vertex map and go to set vertex normal, I can define the smoothness of those 2 faces, okay? And if I click OK, then it applies the smoothing angle and smooth on the surrounding area, but keep the hard edge effect between those 2, okay? But here it's smooth now. They are combined over here. The 3 different data that we have over here are combined into one direction over here with 2 points, I mean 2 vertex normal, and another one that is here that is relative to this face, okay? So now we are like this, right? So to sum up this talk, and just to remember and show you this, if you are using Python scripting, you understand this way, okay? If you have the crease by smoothing angle to true, and you have the smoothing angle to 40 degrees, basically you are in hard surface mechanical shading style, right? If you are into the smoothing angle, true smoothing angle 179 and smoothing angle activated, then you are in an organic mode, right? You have everything soft. But then, as we've told before, if you are looking at the hard edge workflow, it overrides the data, right? So as long as you have the hard edge set to some edges, it creates some kind of an override, okay? So it lets you define the value and the shading of this area. And then finally, we have the third one with the vertex normal. So you still have the smoothing angle defined in your material. You have still some hard edge that you can after delete if you want, if you will. But the vertex normal, as far as it's created on the different points, is overriding the smoothing angle value in the material as well as the hard edge map. Okay, so this is something to remember when you are working with vertex normal. The vertex normal is overriding the all other workflow. So here, if I delete the hard edge, I don't use them anymore, I can still edit the vertex normal, but I cannot no longer use the selection of the hard edge to define that this one is soft. You see, it didn't work because we have the vertex normal. So as long as I delete this, and I can, of course, go back to the hard edge mode by clicking here on convert to hard edge mode, I can clear the smoothing groups and remove the vertex normal, but I can keep the selection. You see the shading have a little bit changed, but still we keep those hard edges and this one smooth. Okay, so if I select the hard edge, we have those selected and defined as hard edge, but this one is still soft, right? So we've talked about the hard edge workflow and the vertex normal differences. And one thing to notice is when you are defining some materials with some settings, some are really important to set when you are setting the vertex normal by the menu vertex normal, vertex maps, and set vertex normal. So here is one example where those objects, this item, this mesh, this material, and in the material, I uncheck the weight by polygon area. So if I check it, you see that the shading is a lot different. So over here, without and with the weight by polygon normal, it's changing a lot the way the normals are calculated, right? So in this case, for instance, on this cube, you see that we have a perfect cube on this one. And so the size of those faces are the same. So even if you enable the weight by polygon area, you didn't see the difference on these pieces, right? Not that much. You barely cannot see it. And that's because of the weight by polygon area. So if I isolate this part, you see totally how it's changing a lot the effect. So if the weight by polygon area is unchecked, the weighting and the angle of those normals is barely 45 degrees this way, and same thing over here. So it looks completely soft, right? But when you are checking the weight by polygon area, one area is bigger over here, so it takes the priority over these faces right over here. So same thing can be seen on this cylinder, and if I uncheck, you see that this one is much more bended, and over here more bended than when the weight by polygon area is enabled. So now that we've seen the influence of the weight by polygon area with the material, it also affects the vertex normal when you are setting those, right? So I will show two different meshes, one with the weight by polygon area and one without it. And as I select those, I will set the vertex maps. So set vertex normal. And we will see now with the view show vertex normal, the difference between the two. Okay, I have to check again the tool. Okay. So we see that over here with the weight by polygon area, as the cube is shrinked and not even a cube now, we see that the priority is put onto this area over here. So this is the reason why the normal are pointing this way. If you select this one, and we will probably isolate those. If I press Shift, I enter into a specific space, apparently, with the normal. Okay. Okay, so we have here the twice. I will show those on the right side, and you barely see the difference. This one is evenly spaced onto this area and to this area. You see the angle is regular, even if the shape is have some disparity on the shape. So big area, small area, but we have the same result. And on this one have bigger priority because of the area, and this one not. Okay, less. So this is very simple to understand, but you have to check, of course, your Vertex Normal Maps when you are checking those. So micro beveling items gives you this kind of shapes where some highlights can be catch on the edges, and this is a basic example where you can see the low poly model is not that much high in polycount, but the look and feel of those elements directly from scratch with this is pretty good, and putting some micro bevel on those elements gives a better representation of the real shape. So I will jump back to an example scene, okay? So without further ado, we will talk about this, and I will show basic things on those tips. So basically, when you take data from CAD modeling, CAD model, you might want to get those better shapes, right, to work with, but they are not coming like this way mostly. So I will show up this on this part, and the high polygon mesh that is coming from SolidWorks actually for this example. You see everything is triangulated, and mostly it comes triangulated, sometimes not, but it can be difficult to work with this into a real-time application for such as HoloLens stuff or mobile and tablet and stuff. So you can use, of course, normal maps and do some bakes, and you can get pretty good result, right? But it takes a lot of memory because it's not just inside the mesh. It needs meshes and textures. So what I was making usually is creating this low polygon model from this high polygon mesh at first, and micro bevel it to put some more details and highlight that can catch the light, okay, and the reflections. So this is one example, right? And you will probably say, okay, if you take a look at this one, you have basically a lot less polygon count. So here we have about 800 polygons, and the bevel one is a lot more, probably. Basically half, double the count, right? Because we micro bevel those edges on all the hard edges. We bevel those with the chamfer, not the bevel. Usually, and nicely in the latest release of Modo. The edge transfer is pretty good doing those micro bevel stuff. So I'm only using actually one edge, right? And I've added the the Vertex Normals that are located over here in the other maps. And so, yeah, usually when you get the data from a CAD modeler, you get the Vertex Normal data into the mesh, right? So I will just make the invisible selected inactive, and I will probably also show them twice. I will move this and match the position of this one back again. And so here you have some vertex normal, right? If you take a look at those vertex normal, you can go to the view and show vertex normal, and you see they are all hard setted. For most of them, I mean, all those edges that separate and have some chamfer over here. So of course it separates those vertex normal data from this location to this location, okay? There's a disparity between the two, even if that's the same point, right? But so it shows us that when you are working with real-time data in Unity or Unreal, you can get those vertex maps saved, right? And it's basically set by the base material. So if you delete this vertex normal, you will get the base material, or the material that is on the mesh. Or actually, I just got one. Those are just matte caps. And over here into the smoothing angle, you will see that we have actually 60 degrees. So it means that it creates some hard edges directly from this smoothing angle. So if you define, maybe we will go a bit higher than this, okay? So I will put 100 degree. You see that on every part where you have less than this value, it starts smoothing those elements. So this is what you can get if you didn't have the hard edges workflow set, right? So if I go back and get back to 60, this is basically what you should have with the Vertex Normal. If you didn't have the Vertex Normal coming from the CAD data, you should maybe use I will not show this here. We have in the game content the Vertex Normal tools over here. So you can convert to an hard edge workflow if you have the Vertex Normal and you want just the hard edges. So you can select the hard edges, and you see now we have those hard edges, and here we have a smooth transition between the two. So this is basically what you can use to create and set the hard edges or not. But what I'm talking today is not using this kind of workflow where you have, okay, so I will show back the model, the starting model over here. And this start model have already hard edges, okay? If I select those hard edges, let me show you back. I have to set the hard edge and convert to hard edge over here. Okay, so now we have those hard edges. From this perspective and this position, probably if you are using and displaying this object in Unity, from this point of view, you didn't see the bevel, right? You didn't see those informations, and it's perfectly okay because it's really small in terms of polygon density, right? But you have those hard edges that define the smoothing angle between this surface, this round one, and this flat one over here. But as soon as you create some bevel on it, so I will use the edge chamfer over here and chamfer those hard edges, then you end up with this, okay? It's perfectly fine. and it's creating this flat area. But it didn't give an appealing graphic of this item, even if that's a mechanical part, okay? So to me, it's important to not use this kind of methodology, but use the Vertex Normal to guide and set up those data. So I will go to the base material and set this a bit higher, okay? So if I put 179, it should basically set them all soft. But actually we have hard edges, right? So the hard edges is overriding this material, base material smoothing angle defined. So with the weight by polygon area, it says, okay, we have all here smooth elements because in between this edge is probably set to smooth, so it calculates that it's smooth in this area, but not on the border, right? So all across this boundary of polygons, it will create some disparity between this face and this face at this point, right? So if I remove and make everything soft, then you see it show the object this way, and it seems like it's okay, but it's not. And I will talk about this right now. So in order to show and see what's going on and to display and for the purpose, I will show the Vertex Normal. So I will go to View and show Vertex Normal over here. Okay, and as we still are working with just the smooth, I will not show this menu, but just the direct menu. That will be much more simple. Okay, so I will open it directly from my Smonster shortcuts. And so actually we have just soft elements, okay? The soft edges is set on H edges. So there's no hard edges tags, of course. But now if I make this just Vertex Normal, so I have the object selected, and I will go to Vertex Map and set the Vertex Normal. We give it a name and use the smoothing angle we have. And now we can see the Vertex Normals, right? On the side, on each point, we have a direction. One interesting thing with the latest 15 release of Modo is that the back faces normals are not shown. You see, this point over here is not shown as a transparency because it's behind it. But sometimes when you have multiple PCs into the same layer, it didn't make the difference. So of course you see those. But anyway, we will concentrate on this part over here. So now if I look from the side, it looks perfectly right on the right side over here. You see that all the Vertex Normal are pointing to the center probably. So it should be okay. But if I look from maybe the side over here, you see that there is some kind of an offset. It's tilting and not really flat anymore because this edge over here, I cannot use the loop or the magnifier, but you see that this one is tilting up a bit and this one on the right and this one on the left side of the shape. So it's not really correctly set, right? And even the point inside the torus are pointing in the wrong direction. So what you should do in order to fix this, because actually we have this point that is pointing this way and this one over here this way. So if you look at this, I will go back to the back, you see that those points are pointing in not in a direction that is not representative of the shape, right? The shape should be flat completely, So go back to here. So those should be totally parallel, right? And they are not. So in order to set them correctly, you should define that all those faces should point out to the minus x direction. Here we have the axis, the center of the object, and all those vertex normal should point to minus x, right? Actually, they are not looking at the same direction. So this is why when you look at it, sometimes it looks a bit bumpy, right? It's not totally flat. And to remedy to this, what you can do is actually hide the rest of the elements over here. So just keep this face, those faces selected. And as you can see, the reflection of the matcap is showing that there is some bumpy effect on it. It's not totally flat. If it should be flat, it should show only one color, right? All across, because the reflection should be in getting just one point of color, because that's one direction only. But here there's some reflection that is showing up, and you see there are some deformations. So it's not working as you should, right? So the vertex normal can be driven with some tools. So here we have the vertex normal over here, and I will create a new mesh on this area. So I will just create a new mesh over here. So N, and I would drag and drop it onto the start object. Make sure, so this is the basics, okay? You shouldn't do this with some of my tools because that's automatic in some ways. But here we have to define that this mesh should share the same center and the same rotation. So this is why I put it this one into as a child of this object that we are editing. So this mesh now is sharing the same position, right? The same center and the same rotations. So now from here, you can say, okay, I will show the start. I will show the object back. Okay, so 5. I will select the faces, hide the rest, but define the work plane to the selection. And now we have the work plane set to this flat area, and we have the center over here. So we can go to the mesh over here. I will probably show the unselected items in a different way, probably, just to show you that we have still those selected and visible, not selected. So in the mesh here, this will be the background data, right? So I would just create a square from this perspective. What? I don't see it correctly. We'll just use the pen tool. It would work the same way. Okay. Okay, I hide it so I didn't see it, of course. Okay, so we'll just delete this and create again just the square. That will be much more simple. So now we have the square, and we are roughly positioning it to get the bounds of this area. And as you can see, this face is pointing in the same direction as what we have selected before. So now I can go to the vertex maps and create a vertex normal map on this mesh. So instead of clicking on here, new map, I will go to here, vertex map, and create set vertex normal to this one. So now we have some data, right? You see that the form point have the vertex normal data, and those are pointing in the same direction because they've been set from this only one polygon. So they are all looking at the same direction, right? They are basically completely flat. So it's totally perpendicular to this face. So it's the data that we want from before. So if I select back the first mesh that is here, okay, and we want to transfer those data, as you can see here, you see the little offset, right? You see it over here. I will go to the top view, the right view. Okay, so on the right view, you see that there's an offset over here. And now I will just show the start mesh and the background mesh we just created. So I will hide the other meshes, and by selecting the start one and go to the tools over here in the Vertex Normal tools, you can get them over here in the normal map tools over here. It's the same. You can click here and transfer the vertex normal from the background mesh to the start one. Okay, so this is what we will do, and you just have to make sure that you have no rotation on the start one and the background one. They should share the same rotation, right? And basically, if you have 0, 0, 0 on XYZ rotation, it's much better. So you click OK, and now those vertex normal are pointing in the right direction, in the -x direction. So I will just go back, Control Z, and you see they are offset. So if I transfer, I'm basically setting those hardly in the hard way, right? But now, if we go back and show the mesh entirely, we should go to the perspective and remove the work plane. So go to the Polygon mode and now show back the shape. So I will display it again without the wireframe and without the vertex normal shown. You see that now, even if I'm hiding the rest of the selection and show these pieces, you see that all the faces have the same color exactly, because they are totally flat. So they took the same, the only one pixel in the matcap shader environment. So it's basically flat, right? This is what we should have, basically. If I'm going back on this backside, you see totally the effect. It's much more bumpy over here. It looks like it's a bit bumpy, and here it's completely flat, right? It should get the reflection much more correctly. So this is what you should have and should do. Same thing over here. So on this one, it's a bit different. You should have to select the loop, okay? Copy it, go back to the background mesh. So we will show it again also. Okay, so now we have just a flat polygon. We will just delete this and paste the data we've took from the poly loop that we've selected. So now I will select everything over here, all those edges, and extend it a bit to get a bigger bound of the data. And with this selection, I will also again set the vertex normal. Okay. And now if we go back and show the vertex normal, you see that all of those are pointing in the right direction. So I will select back the start one, and you see that here we have the wrong vertex normal data, and here we have just this area, the flat one that is correctly set. We have to set those over here, okay? So to correct those, we have the background, we have the start, we will hide the rest. So we have just 2 objects selected and 2 objects shown. And from the perspective, I will just, again, in the start mesh, select all the polygons over here, the poly loop, hide the others, okay, because we just want to treat those areas. And with the background, visible, still visible, we will transfer the vertex normal, and you will see that here the vertex normal will be shifted and corrected. So now they are correctly pointing in the right direction, right? Y up for the topmost, okay? So this is the basic, right? You should edit those this way, and it takes some time, right? So this is why also I created my script and commands for Smonster Kits and especially VeNom. So this is why I'm editing those actually a lot with this tool. So I will continue on the next part and talk about some tips and tricks to make this process a bit more quickly using the kits, but also not the kits. So there are some things to know, and I will continue on the next part. Okay, so talking about the disparity and the side count that you should set. If you are working with polygons models and it's working with all the different workflow, but you should have some mechanical parts like those, and the decision to have the same amount. So for instance, here we have the CAD data that is a lot more tessellated, right? We have a lot of polygons over here that is set, and those are basically too much for a low polygon model, right? So over here we have 88 edges, so it's a lot of polygons. And also same thing over here, right? We should have the same amount. We have 88 edges. It makes sense for a CAD engineer or artist, if you say, to make those the same refinements, right? Because they are old by drill and CNC machine, so it's perfectly normal and it totally makes sense. But if you want to make those as a low polygon model, you might want to reduce the polycount and distribute a disparity between different parts in the mesh. So you cannot get 88 polygons, of course, here, and same thing here, and same thing here, as well as this one. So it didn't make sense, and for that purpose, I suggest you to look at this other mesh over here, where I've set the vertex normal with my tools to make this completely flat and correctly set. So here we have right reflections. I will not go back maybe in a moment on how to achieve this result, but it looks a bit simple to talk about those elements. So over here, I have choose to get a disparity between the amount of sides bring to this hole over here that is a bit big. That's the biggest one in this model. So we have 20 polygons, right? And it looks to me it didn't make sense that those also should be 20 polygons. So there are 16 now. And same thing over here, to have 12 polygons, and even those that are just 8 polygons. And I'm not talking about triangles, we are just talking about basic polygons, so don't do some comments on this. We are just talking about quads, actually, but the mesh is triangulated in most of the areas, right? It's perfectly normal. So it makes sense, yeah, to distribute some side counts differently across the mesh, because from this perspective and this view, you didn't have to see and get the same amount of edge sides on those holes. It didn't make sense. So it's perfectly fine if you get those 8 sided polygons and this 120. Okay, it works completely well from this perspective and at this size. Okay, and it still feel it's a drilled object from a mechanical part, right? So you can get this kind of example, but I will show also another one over here that also show up this logic. It's a bit exaggerated on this example, but you might understand the purpose. So here I have this outside area that is 64 polygons, right? I will show back the wireframe. So we have 64 polygons over here, and here at the center we have just 32. I probably should go to about 40, or so you just have to get the rules to use power of 2 each time, or not power of 2, but every 4 polygons. So basically, like I do usually with the rebuild tools, is basically use this set. I will get it over here. Okay, rebuild with cylinder, and I have 6, 8, 12, 16, 20, 24, maybe 32 and 48. Those kind of numbers works really well. So you can define that, of course, this one is maybe a bit less, too low for the purpose. Probably 40 should be better to retain the roundness of the shape. Okay, but from this perspective, it totally makes sense to have this one not 64 but about 40 polygons over here. So on this one, I just make some Bevel holocross to create the micro detail of the object, and it works perfectly well. But also on this area, if you take a look at this one, there's a double inset over here, and so we have over here a certain amount of polygons, 20 polygons, okay, with those in between polygons over here. So basically that 16 for all the round area, so 8 and 8. And here, as I have this shape a bit smaller, I reduce this amount. So I have 16 polygons over here, and here I have 20. So it makes sense, and from time to time, here and there, you will optimize the shape and the polycount, even if you are making some bevel. So as we are making some bevel over here, we are basically doubling the polycount of a basic model like the start one we've shown before. So it makes sense to reduce those polygons count. Same thing over here. You might have some bolt over here that is covering this area, but if you want to show the piece, only this piece separately, you might want to get some optimization. So here we have 16 polygons, and over here we have not 5, we have a certain amount of polygons over here. Okay, 12 polygons instead of 16 for the biggest one over here. So it makes totally sense to me that the disparity of the topology and the polycount on the round elements should be treated as well. So there's optimization, and I should probably collapse those and merge some of them. But anyway, it's working well, right? At the end, you want to get some kind of a mechanical part with some small highlight, and this is probably good to know about the topology with the low polygons elements. Okay, so here we have this object that is also coming from CAD data. It's not that much triangulated. Some part was, some not. But the shape was like this, okay? And it's perfectly cool. You have a round area over here that is correctly soft, and this one over here that is also bold in it. And it's totally fine with the hard edge system, and it works pretty well with the Vertex Normal coming from the CAD data, the CAD model. But so when you want to create the same kind of mesh with the Vertex Normal editing, you should have to edit and use some tricks to, I can say, to fix some issue. So over here, I have this one formed with different size of the bolt over here, and I've edited some of the Vertex Normal, because if you just delete those and get the data from scratch, you see that there's some highlight over here because we have the same smoothing angle applied to every faces, and it lacks some data to tweak and, I mean, get this completely correctly flat or round from this perspective. And you see there's some highlight over here as well as here also. So this is why also I wanted to use some of the tools like the VeNom tools in my kit to flatten this area to be sure that this is completely flat and like it was cut, right, from the CNC machine. Same thing over here. You see there are some tearness. I don't know how we can say this, but you see there's a lot of artifact over here in the smoothing. So it didn't work that well as the bumpiness of this area. So to make this, you have to use some tricks, right, to get this a bit more controlled and correct Vertex Normal data. So here it's perfectly flat. As we said in the start, in the part A features, you have to transfer the Vertex Normal from a flat mesh to those faces, to those points. And also this one, use a round one to make the trick. So of course, here we have a cut, right? But it works the same way. So I will just select some of those edges. I will go back and enable the selection to get back the visibility of those, right? So I will probably duplicate this, copy this to a child mesh. So I will just use one of my tools to just copy this as a child to a new mesh. That will be much more simple. Okay, so now we have here the object we want to treat and the child one that is the same mesh, right? So I will just hide the rest and get just the edges over here to start building up. Or maybe I will just use this trick with the MIFA tool. So I select those edges and I will select all the polygons over here, and I will just revolve those edges around and make this completely circle as a cylinder from this Y direction over here at the center. So I would just open up my tools. This is basically a radial sweep that you can use. And I have to check here, okay, local mode, Y, and 32 edges. So now I have this, just align the polygons and flip them to get this shape. So now this shape is completely what we want to achieve, right? We want to get the data from this shape back to our model, right? So I will just make this one a bit higher, taller, to get the boundary of the first model, right? And also I will just divide it multiple times to be sure I create some more data on the shape. And I will delete the Vertex Normal over here and create them again to set them up from scratch and with a clean zero out the data. So set vertex normal. Okay, so now we have vertex normal on this one. We will show up back those elements. And here we will delete the vertex normal, okay, just for the purpose to show you how you can get back the data from this background mesh, right? So we'll just rename this background, select back this, and we will just show and select the area we want to check and correct, right? So now that we have this area selected, I will just select everything, all of those. That should be much better, probably. So now I will hide the rest and convert this selection to just point. And all those points at the surrounding, the boundary of this area, will get the data from the background mesh. So we show the background, and now we go to the transform vertex normal. So we didn't set the vertex normal, so I should go back. Sorry. Okay, and hide the rest. And without further ado, use the transform normal, and now we have back the correct vertex normal. And if we show back the mesh without the wireframe, you see that now it's corrected. We have not so much. There's a bit artifact here and there, but that's much better, right? But also one thing interesting is that here we have some edges count that is a bit different from the outside to the inside of this falling part. Okay, here we have 1, 2, 3, 4 edges over here, and here we have a lot more definition, right? Because we've made some falling in it. So without looking at the Boolean futures, I decided to create some more refined outline on this. And of course, what I've made, of course, during the modeling part, is to select all those points, maybe select two vertex, and with the background mesh visible, this is where you can use the background constraint. I will check the double-sided and the vector mode to use the scale tool from the reference of this object. So if I get this object selected, I will click here and I will use it as a reference system in Modo. So this is a really nifty features in Modo. You can define that the origin will be this object. And so from this, I will go back to the point, select the scale tool, but from the origin, okay? As it's unrolling from this direction, right? I will use this instead. So I will push them out, use the background mesh constraint active, and now push them back. And now they are perfectly in position on this round area. So it keeps preserving a bit more the data of the background mesh. So if you didn't do this, some of those edges should be just not this way, but I can say a bit different, and or sharing the same not coplanar, but the same direction on those edges. So it's much better to do this way, having some background object where you project and push those points. You have to do this also on a more smaller area on this one. So probably disable the mesh constraint, push the polygons with the push tool and push them inside, for instance. And now we can also probably select those over here, convert this to vertex. I will make the selection quickly. Select the vertex, and again, use the trick to move those with the mesh constraint, the background mesh constraint. Oops. Get the selection and move them back. Oops. Not the right directions. We'll do this again. Okay, this way. So you can define this way, the way it should work. So of course you have to rebuild and reproject the Vertex Normal. But this is one features that you have to check. Let's go to the next last tips. When you are creating this kind of mesh, right, you should have a mirror part from this to this, right? So you probably have to work in just one part and then mirror it. And so you end up with this kind of edges at the center, and without doing this too much complex, you just have to think, okay, this is completely flat on both sides. I should have to remove this edge, okay, because it can optimize the polycount on all those elements. So you have to select those and use delete to delete the edge, and probably triangulate this one again and get back this kind of shape where you just optimize the polycount by removing some of the points, some of the faces over here. Same thing should be done over here. So I will use the collapse command, just show it here in the edges. So I can use the collapse on those. Sometimes you have to be sure it's not messing up some of the alignment of those edges on the side, but mostly it should work. So you should have to do this kind of things. Or maybe not for this purpose, but I will probably do this a bit differently, using a merge of those points together and removing by this way some of the faces that were in between those areas. Okay, so now it's perfectly working, even if it's tearing a bit too much the triangles. You can check those and organize those a bit, but also move this one at the center. So some of them could not be removed, right? If you try to, of course, merge this point with the latest one over here, it might didn't work because it will tear off some of the edges and they will overlap, right? So it's not working at some point, but you can do this for some of them. So don't hesitate. Same thing over here. I was getting this area mirrored with this one. I just removed this middle edges over here. So don't hesitate to edit the mesh afterwards. You will end up with better topology at the end and smaller polycount. So one thing I should mention is that instead of getting this, I was working previously to create the bevel and keep those edges. Because if you want to create some bevel on hard edges things over here, you have an n-gon. Okay, this is one n-gon that you might have. And this n-gon should get some starting point and connection from the outside to this area. You cannot select this edge and delete it. If you delete it, or even if you delete it without deleting the vertex, Modo couldn't. I'm actually pressing Shift Delete and it didn't remove this edge because there's no connection from outside. So it might create just a face that didn't have the hole. So when you want to create this area with correct shapes, I will recreate this area with just those selected polygons. So let me do this real quick. Control X, Control V, delete those. We will select those, select this face, and use the tool. Oops. Move this to snap here. Okay, reconnect those. Okay, so now we have basically the starting point with the hard edge kind of shape. Okay, so the vertex normal is messed up, of course, as we've changed those. But as you can see, if I have this edge moving like this way, okay, I'm tearing off this one this way, it's not aligned with those points, right? So those points are aligned and this one is shifted on the side. And if I want to create this on this area, some bevel, it will not work as I expected. So I will just use my quick menu to create a bevel. Here you didn't see any squeezed elements, but most of the times, if you have triangulate meshes like this and you try and you want to make a bevel on this, it will not work correctly because you have star edges across this region and some of those are really close to each other, so it might didn't work, right? You see it breaks up. So the best solution when you want to do some kind of bevel on those hard edges is to have just only one edge this way. The better is probably to get this aligned correctly. So this way it works much better if you want to make this area soft too much. I will go back to 25. Okay, so this is the tricks I'm basically using every day. I hope you enjoyed this video that is talking about those, and if you have any questions, some of those questions, I'm happy to look at those. I will continue working on this model. See you. Bye-bye.